Let's start with the questions. So the first exercise question is, electric current of 2 amp pass through a wire of resistance 25 ohm. How much heat will be developed in 1 minute? So this is the first question. Current is 2 ampere, resistance is 25 ohms, time is 1 minute, that is 60 seconds. So heat that is developed will be given by I square RT. So here I square 2 into 2, R 25, time is 60, so it will give us 6000 joule. So this much heat will be produced. In second question, there is a coil of some resistance connected to battery. Assume that heat developed in coil is used to raise the temperature. If heat capacity of coil is 4 joule per Kelvin, how long will it take to raise the temperature of the coil by 15 degrees Celsius? So the second one, so first of all, what do we have? Resistance is 100 ohms. EMF or potential or voltage is 6 volt. Then change in the temperature we require is 15 degrees Celsius. Then heat capacity of the coil is given. Okay, heat capacity is 4 joule per Kelvin. So heat liberated can be found out using V square over RT by this formula. So this will be heat liberated will be equal to 4 joule per Kelvin over into 15 equal to V square over RT. V can be E here, okay, EMF. So once you put all the values, you will find this T will be here. So once you put all these values, what we will have, 60 equal to E square, so that is 36, 6 square is 36, resistance is 100 into T, so T will be approximately 166.67 seconds. So this much time will be required. Remember what we did, heat capacity was given and temperature difference was given. So heat was equal to heat capacity into change in temperature. Okay, so therefore 4 into 15. In the third question, specification on a heater coil is given. We need to calculate resistance of the coil and what will be the resistance if power can be up to 100 watt. So now the third one. So first of all, in the first situation, we know P equal to V square over R. So R will be V square over P. So R will be equal to 250 whole square over 500, which will give us 125 ohms. In the second part, power needs to be 1000 watt. So R will be V square over P, 250 square over 1000. So it will give us 62.5 ohms. So only this much difference. In question 4, we have heater coil made by nichrome wire which can operate at 500 watt. when connected to 250 volt supply. Now we need to find the resistance of coil, cross section of area of wire. If it is 0.5 mm square, then what will be the length of the wire? And if radius of each turn is 4 mm, how many turns will be there in the coil? So this is the fourth one. First of all, resistivity 1 into 10 to the power minus 6 ohm meter, power 500 watt, potential or EMF 250 volt. So A part resistance can be found out using this formula, by the formula of power. So it will give us 125 ohms. Then area is given, in meter square it will be like this. So resistance we know rho L by A, so length will be RA over rho 125 into 5 into 10 to the power minus 7 over resistivity, which is 1 into 10 to the power minus 6. So from here length comes out to be 625 into 10 to the power minus 1 or 62.5 meters. Next part, now we know that the total length will be equal to number of turns into the circumference. Okay, so 62.5 equal to n over 2 pi into r is radius is given 4 into 10 to the power 3. So n will come out to be approximately 2500 turns. So this many turns are there. In question 5, a bulb with some rating is connected to power supply of 220 volt situated 10 meter away using copper wire of area of cross section 5 mm square. How much power will be consumed by connecting wires? Resistivity is given. Fifth one, voltage is 250 volt, power is 100 watt. R will be V square over P. So we will have 625 ohms. Resistivity can be found out by now resistance of wire can also be found out by this formula. So it will be 0.034 ohms. So now the effect in resistance. So okay, the effective resistance will be 625 plus 0.34. So this will be our 0.034. So this will be our effective resistance 625.034 ohms. So current in the conductor will be V over I 220 over 625.034. Now power will be I square R. So power supplied by one side of connecting wire will be I square into R of wire. Okay, this is the resistance of wire, remember. So 220 over 625.034 square into resistance of wire 0.034. So power supplied by both wire, by both, will be twice of this. So 2 into 220 625.034 whole square into 0.034. So it will give us 0.0084 watt or 8.4 milliwatt. Now question number 6. An electric bulb is given. When it is connected across a power supply of 220 volt, it consumes a power of 60 watt. If supply drops to 180 volt, what will be the power consumed? If supply suddenly increased to 240 volt, what will be the power consumed? So this is the sixth one. So ultimately what we have, EMF or voltage is 220 volt, power is 60 watt. So R will be V square over P or E square over P, 220 square over 60, which will give us 220 into 11 over 3 ohms. So now in the first situation, if EMF is 180 volt, so then power will be V square over R, 180 into 180 into 220 into 11 over 3, so it will be over here. So power will be 40.16 watt. And in the second part, EMF is 180 volt, 240 volt. Power will be V square over R, 240 into 240 into 3 over 220 into 11. So power will be 71.4 watt. Now in question 7 we have a servo voltage stabilizer which restricts the voltage output to 220 volt plus minus 1%. If an electric bulb rated 220 volt 100 watt is connected to it, what will be the minimum and maximum power consumed by it? This is the seventh one. So the output voltage is 220 plus minus 1% volt. So 1% of 220 is 2.2 volts. So 220 plus minus 2.2 volt. Now resistance is V square over P, 220 whole square over, power is 100, so 484 ohms. Now for minimum power consumed, V potential will be minus, okay, minus 1%, that is minus 2.2. For minimum voltage will be less, okay, for minimum power consumed voltage will be less, so therefore minus. And minimum how much? Minus 2.2 volt, so 217.8 volt. So current will be V1 over R, 217.8 over 484, which will give us 0.45 ampere. Power will be current into voltage, so it will be 0.45 into 217.8, 98.01 watt. In second situation, for maximum power, voltage will be 220 plus 2.2 volt, that is 222.2 volt. So power will be V square over R, which will give us 102 watt. So minimum power and maximum power. Now in the 8th question, we have an electric bulb which is marked to 20 volt and 100 watt. Will get fused if it is made to consume 150 watt or more. What voltage fluctuation will the bulb withstand? So this is our 8th one. V 220 volt, power 100 watt. Resistance V square over P, 484 ohms. Now if power is 150 watt, then what will be the voltage? It will be root PR, root 150 into 22 into 22, or 484. So this will come out to be 22 root 150, or we will be approximately 269.4 or approximately 270 volt. So this, if power is 150 watt, voltage will be this much. So this much voltage the bulb will withstand. Now in question 9, an immersion heater rated 1000 watt and 220 volt is used to heat 0.01 meter cube of water. Assuming power is supplied at 220 volt and 60% of power supplied is used to heat the water, how long will it take to increase the temperature of water from 15 degrees Celsius to 40 degrees Celsius? So this is the ninth one. So power is 1000 watt, voltage 220 volt, resistance can be easily found out, come out to be 48.4 ohms. Mass of water 1 over 1000 into 1 over 100 into 1000, that is 10 kg. Heat required to raise the temperature, that heat is called specific heat. It will be M S del T, specific heat constant, change in the temperature. So 10 into 4200 into 25, 105 4 zeros. Heat liberated is 60%. So V square over R into T into 60%. So equal to, the total heat is 105. So from here T will be 10500 over 6 into 1 over 60, or 29.16 minutes. Small t is representing time and capital T representing temperature. In question 10, electric kettle used to prepare tea takes 2 minutes to boil 4 cups of water. 1 cup is approximately 200 cubic centimeter of water. If room temperature is 25 degrees Celsius, If the cost of power is given, we need to calculate cost of boiling 4 cups and what will be corresponding cost if room temperature drops to 5 degrees Celsius. So this is the 10th one. Volume of water boiled is 4 into 200 cc, that is 800 cc. T1 is 25 degrees Celsius, T2 is 100 degrees Celsius. So change in temperature is 75 degrees Celsius. Mass of water boiled is 800 into 1 cc gets converted into gram or 0.8 kg. Next, heat is ms del T. So 0.8 into 4200 into 75 degrees Celsius, 252,000. 252,000 joule. Now 1000 watt hour means 1000 into 3600 watt second. So 1000 into 3600 joule, remember. So number of units will be 252,000 over 1000 into 3600 0.07, so 7 paise. This was the A part. B part. If temperature difference is 95, then number of units will be 1000 into 3600, 9 paise. It will be 0.09, that is 9 paise in this situation. In question 11, coil of electric bulb takes 40 watts to start glowing. If more than 40 watt is applied, 60% of the extra power is converted into light and remaining into heat. Bulb consume 100 watt at 220 volt. So we need to find percentage drop in the light intensity at a point if supply voltage changes from 220 to 200 volt. Eleventh one, power is 100 watt, voltage 220 volt. In the first case, excess power is 100 minus 40, that is 60 watt. Power converted to light is 60%, that is 60 over 100, 36 watt. Case 2, power equals 220 V square over R, 220 over 440, 82.64 watt. Excess power will be 42.64 watt. So power converted to light in this case, 42.64 into 60 over 100, 25.584 watt. So the change in power, 36 minus 25.584, 10.416 watt. 10.416 watt. So required percentage is 10.416 over 36 into 100. So 28.93%, this much change. Okay, so from the original 36 watt, 29% change will be there. That is 25.584 watt will be there. So from 36 watt we will go to 25 watt approximately.